Hi guys, how are you? Hari, Srinidhi, and Divya, you three are here. Anybody else is here? Hi guys, so hopefully everyone is here, those who want to join the class. So, how have you tried solving questions from geometric progression? I asked you to solve, right?
Yes, sir.
So, are you facing any trouble solving problems in geometric progression? I mean, not the mean I haven't even started yet. So, please tell me if you have issues with that. Anyone? See, it's okay. We can see if we are learning it, we should learn it properly, right? Okay, I'll share my screen. You guys let me know if you are able to see this. Okay. Can you see the screen?
Yes, sir.
Okay, right. Sequences, let's do it here. Okay. So how many of you did solve that problem I gave in previous class? How many of you tried? You are able to see the screen? Yeah. Okay. So we were doing geometric progression, right? Geometric progression. Everyone is having NCERT book now? Yes. All of you have NCERT book?
Yes, sir.
Okay. Let me download it. Okay. Can you give me just 2 minutes? I'll download the book. I'm really sorry. I should have done it before. Which exercise is that? Geometric progression? Anyone please tell me.
9.3.
9.3. Okay, please open your book page. What page number is that?
192.
182. 9.1 and 9.2. I see AP you guys don't have in syllabus, but you guys have understood AP, right? Do you guys have any solving problems from AP?
No, sir.
AP is okay, right? So let me check GP. Okay, exercise 9.3. I got it. Okay. Okay. Solve the first problem, sir. First, exercise 9.3. Solve the first problem. The 20th and nth term of the GP. So the GP is given to you 5 to 5 upon 4, 5 upon 8. So what's the definition of GP? When do we say the series is in GP?
When that's a common ratio.
When there is a common ratio. That means if this is term 1, term 2, and T3. So T3 by T2 should be equal to T2 by T1, right? Or from here you can also say T2 square is always equal to product of T1 and T3, right? That means if you square this term, this and this, it will be equal to the product of these two. Okay. Okay. So you find the 20th term of this GP. Find T20. So the general term Tn is given by what?
Can you repeat that,
A
sir?
r power n minus 1.
Sorry,
A r power n minus 1.
what is A?
First term, sir.
A is first term, right? So you can also write this is equal to T1, first term. This is common ratio to the power of n minus 1. Why n minus 1? What do you mean by n minus 1? What do you mean by? See, if you are writing n minus 1, what do you mean by that?
Total number of terms excluding the first term.
So how many terms are there total?
19, sir.
N terms.
Yeah, that means that there are total of n terms. Okay, that means we are writing for nth term here. Yeah, that's what we needed. Yeah, please find out and tell me T20, 20th term. Please tell me, or you can see in the book it is also written A20. You can write anything you want.
5 into 1 by 2 to the power 20, sir.
1 by 2 to the power of?
20, sir. 5 into 1 by 2 to the power 20.
5 by
Okay,
2 power 20.
5 by 2 to the power 20. That's what you have said?
Yes, sir.
Okay, Okay, I don't know. Let me find out. So first we'll find the common ratio. Okay, so common ratio you can use T2 by T1, right? Common ratio, let's say R. T2 by T1. T2 is what? 5 upon 4 divided by 5 upon 2. So you can write it as 5 upon 4 multiplied by what? 2 upon 5. Is that correct? So this will be equal to 1 upon 2. Okay. Hopefully everyone is getting it. Now A20 or T20, 20th term, that means will be equal to, we have A, the first term are 20 minus 1. That means A is upon how much? 5 by 2, right? So 5 by 2 multiplied by R. R is how much? 1 upon 2 to the power of 19. That means 5 upon 2 to the power of 20,
sir.
right? Hopefully everyone got this. If those who are having problem here, anybody, so 5 upon 2 multiplied by 1 to the power of 19 upon 2 to the power of 19. So this you can write 5 into 1 upon 2 to the power of 1 plus 19. That's how we get it. Okay, now, okay, solve question number 3. Please solve question number 3. Fifth, 8th, and 11th term of the GP are PQ. This, have we solved this in this class? Did we solve this problem in previous class? Hari, you were there in class.
No, sir.
No? Okay, okay. Solve this.
Sir,
Yes.
what are we doing in this last step?
What we did in
Last step, like in the substituting.
who is this? Divya.
Yes, sir. Yes, sir.
Okay. Were you present in previous class, Divya?
No, sir.
Okay, that's what I thought. Anyway, yeah, tell me where do you have problem?
Sir, in that 1 by 2 the whole power 19.
Here?
Yes, sir. From that
Here
step.
you have, okay. So far this is clear, no? Here?
Yes, sir.
Okay, you know the general term, how do we write like this?
Yes, sir.
Okay, this part is also clear to you?
Yes, sir.
Okay. Let me just write it like that. Okay. I'm writing this again, okay? First, what is first term? We are writing
So
this
5 by 2. Yes, sir.
5 by 2, okay. 5 divided by 2. Multiplied by what is common ratio?
1 by 2.
1 by 2. Okay, 1 by 2. Which term we are finding? 20th? That means
Yes,
n is
sir.
equal to 20.
Yes, sir.
So 20 minus 1. Is that okay? So
Yes,
far
sir.
it is fine, right?
Yes,
Now
sir.
this is just mathematics, solving mathematics. 5, of course, that is also mathematics, but the meaning is right now we are solving numericals, numbers into, can we write 1 upon 2 to the power of 19?
Yes,
Yeah.
sir.
Okay, I'll write one step at a time. So 5 upon 2 multiplied by 1 to the power of 19 upon 2 to the power of 19. Can we write like this? Because both
Yes,
are
sir.
real numbers. Okay. See, if this is p by q to the power of 19. Okay. So you cannot write p to the power of 19 upon q to the power of 19 unless p and q are given as real numbers. Okay. So p and q must belongs to real number. You have to understand this part. There are proofs. okay, based on this, which probably you will be studying when you are doing masters in mathematics. Okay, so the proofs are really, you know, a little bit complicated. It complicate things. So let's not go there. So far it is clear to you? Okay. So
Yes, sir.
can we write this as 5 multiplied by 1 to the power of 19 upon 2 multiplied by 2 to the power of 19?
Yes, sir.
Okay. So anything 1 to the power of anything is what? Any real
1.
number. It is 1. Okay. So 5 into 1 upon 2. Now see, a to the power of p into
Yes,
a
sir.
to
I
the
get it,
power
sir.
of q. Okay. So how do we write this? A to the power of p plus q,
Yes, sir.
right? So
Yes, sir.
2 to the power of 1 plus 19. So this will become 5 upon 2 to the power of 20. Is that okay?
Yes, sir.
Okay, good. Solve question number 3. Anyone else had problem in this? I just want to know. Anyone else? It's fine. See, once it is fine, but every time if you do this thing, so that won't be fine. But it's okay. Yeah. Anyone else? Solve question number 3.
Done, sir.
Shreya, are you there in class?
Yes, sir.
Yeah. Tell me the answer. See, again, geometric progression or this series progression, this is, you know, if you have just the formula, you don't have to, you know, brainstorm in these type of problems. You just, a simple common sense understanding is required. That's it. 5th term, 8th term, 11th term. Okay. So in the problem what's given, the 5th, 8th and 11th term of the GPR PQS. Okay. So 5th term, let's write T5 is given, right? T5 will, you can write A R to the power of 4. Fine. This is given as how much? P. Okay. T8, 8th term, A R to the power of 7. Q. T11, A R to the power of 10. R. Oh, okay, sorry. S, it is given. PQS. Okay. Now you have to show that, that means prove that Q square is equal to PS. That you need to prove. Okay. Or you can prove Q square minus PS is equal to 0. Whatever you want, you can prove it. So let's start from here, left hand side. Okay. LHS. Q. Okay. Let's. Okay. Q, or you can just write Q square. Okay. So Q square, what you can write Q square? Instead of Q, you can substitute this A, this one, the second equation. This is, sorry, this is 1, 2, 3. These 3 are given in the problem. Okay. And you have to show this part. Okay. So we start from LHS, left hand side. So Q square. So just substitute the value. Okay. So instead of Q, you can write A, sorry, my mistake. A R to the power of 7 whole square. Okay, let's write the whole equation is equal to PS. Okay. Now this is equal to P. What is P? P is A R to the power of 4 into S. S is A R to the power of 10. Okay. So what this is A square R to the power of 14, right? So this will be equal to A square into R to the power of 4 plus 10, which is A square into R to the power of 14. So LHS is equal to RHS, right? So proved. Easy, right? You can just write, I'll show you another method. You can just write Q square. Now see, AR to the power of 7 whole square. Okay, that means A square R to the power of 7 into 2. Let me write like that. So this you can write A square R to the power of 14. I hope this much mathematics everyone knows. A to the power of P multiplied by a to the power of q, you add the powers, right? P plus q. If a to the power of p whole to the power of q, that means you multiply the powers, a p into q. I have also shown this before in class, right? So please don't get confused. Now you separate what terms you need. You started from q square, you need p, that means you need the 5th term, you need the 11th term. So separate it such that you can write a r to the power of 4. 1a you are taking out from here 1a you have taken out. Now you can multiply it with a r to the power of 10, right? So the power will get added up. That means this one is which term? A r to the power of 4 is which term? 5th term. Which is this? What is this term? 11th term.
Yes, sir.
Right? So that means you are getting product of T5 into T11. Now from equation 1 and 3, what do you get? T5 is what? P and T. So that means P into S you are getting, right? So you started from left hand side and you proved that this is equal to right hand side. Got it? You can prove any way you want. It's not like there is only one way. We have another way. We can just take the logarithm. We can also do that, but let's not do it here right now. In this chapter, we will be using a few problems. In few problems, we'll be using logarithmic functions. Okay, I have also given the properties of log in previous class, right? Okay. So this was also easy problem. Okay. Solve question number 8. Find the sum of n terms of geometric progression. So root 7, root 21, 3 root 7. Find the sum of n terms of CP. Find Sn. Divya, what is how do you find Sn? The formula, do you remember? Anyone from class?
Sir,
Yes.
A into R power n minus
A
1 by
into
R
R
minus
power n minus 1 divided by R minus.
R to the power of n minus 1.
Yes, sir.
Is it? Who said this?
Sir, Divya, in bracket. Divided by R minus 1.
Okay. N minus 1 divided by R minus 1. Is this?
Yes, sir.
Okay. Anyone else?
A
Shreya?
into R power n minus 1 by R minus 1.
Who is this?
Srinidhi.
Srinidhi. Anyone else? Shri Kruti, you there in class? Yes or no?
Yes, sir. So,
Yeah, tell me.
sir, if R is less than 1, then it is A in 1 minus R.
Okay. If
R is
R is
minus
less than, this formula is valid for what? R is less than 1 or greater than 1?
1, less than 1.
Less than 1.
This one,
Okay.
sir. The
This
one you
one.
have written or what I
This.
This is for R greater than 1.
Okay. R greater than 1. Okay. R greater than 1. Okay.
If R is less than 1, then it is A in 1 minus R power n. Sorry.
Yes, again. Divided by
A
1 minus.
1 minus R.
Okay. So this is R is greater than 1, right?
R is less than.
Okay. R is less than 1. Okay. R is less than 1. Why there are two formulas, two different formulas? What's the difference? So see, let's say this is first one and this is the second one. What's the difference in these two formulas? Why do we need two formulas? See, n is the natural number, right? isn't it? N is the natural number. Okay, now what else? Let's start from equation 1. Okay, let's write it. Sn is equal to a r to the power of n minus 1 upon r minus 1. That's what you are saying. So this is equal to where r is greater than 1. You are saying r is greater than 1. Okay. So I'll take common, take minus 1 common in numerator and denominator. Okay. So a, if I take minus 1 common multiplied by minus 1, so can we write it as 1 minus r to the power of n divided by, see, in the numerator and in the denominator also we are taking common 1 minus r. Is that okay, Shri Kruti? Yes or no?
Yes, sir.
So can we cancel this minus 1 minus 1?
Yes, sir.
Okay, so can we write this as Sn is equal to a 1 minus r to the power of n upon 1 minus r. But this you said it is r should, this is, we are getting r greater than 1, but you said this should r should be less than 1. Why is that? My question is that. Why two different formulas? Anyone in the class? Why do we have two different formulas? If can anyone explain this? Because ultimately when you are writing r greater than 1 or r smaller than 1, both are same, right? You just see, you just take common and you are getting the same formula. Why is that? Huh? Okay, so this please take down this as homework. Okay, those who don't want to do, it's fine. That means you don't want to know at all. So this will be your homework. Please tell me tomorrow, please tell me why we have two different formulas for Sn. Okay, now use any of the formula here in this problem. Do it. How much answer we got? See, finding answer is really easy, but why we are using this formula, that is actually important here. Finding answer is really easy. Geometric progression, arithmetic progression, it's very simple. Yes, anyone? Tell me the answer, someone. First, tell me the value of a for this problem. Shri Kruti, you got the problem, right? What I'm trying to ask you here.
Yes, sir.
Okay, so you will be the person I'm asking this, okay, tomorrow. See, others, if you will find, you are very much welcome to answer. But definitely, well, I will ask you and Nidhi as also. Both of you have answered this, right? Hari, Murli is there in class? Okay, tell me the answer of this problem. Anyone? See, a value given, Divya, a value is how much?
So root 7.
Root 7. Naveen, are you there? Acha, you will not answer. Ashwin, Sham, anyone? Hari, Haran.
Yes, sir.
Okay, what's the value of r, Hari?
Root 3, sir.
Root 3. How you got root 3? Just T2 by T1, right?
Yes, sir. That's what, sir.
Second term by first term.
Yes.
How much? What was the second term?
21, sir.
Root 21 divided by
Root 7, sir.
root 7. How much you will get? Root 3.
sir.
Anybody is having problem, so I can explain how it is root 3. Okay, this you can write combined root 21 upon 7. So this will be equal to root 3. Okay, fine. Now, what do you need? Sn, right? Sum of the first n terms. Okay, so Sn is a 1 minus r to the power of n upon 1 minus r. Or if you want, you can use this a r to the power of n minus 1 upon r minus 1. Okay. Anybody is having trouble why I'm doing this?
Sir.
Yeah. So I don't see. I'm. You can use these two formulas. Tell me. Now Sn will be equal to A. The first term is √3 or √7. Sorry, √7 multiplied by 1 minus R. How much is the common ratio? √3. √3 to the power of n. Fine. Divided by 1 minus √3. Isn't it? Yeah. So that is your answer only. But if you want to expand it, or you just want to simplify this, or suppose there is some proof that you have to prove this, some other value. So what you do, okay, let me paste it. So you can just play with this equation. What you can write, √7. Okay, √7 is, let's keep it outside. What you can write, what else you can write this one? Okay, let's write 1 minus √3 means 3 to the power of 1 by 2 to the power of n res upon 1 minus √3. This will be equal to √7. Okay, 1 minus 3 to the power of n by 2. Fine. Divided by 1 minus √3. See, again, this is again one of the solution. If you want, you can expand it even more. What you can do, you can rationalize this. So you can multiply it with 1 plus √3. 1 plus √3, multiplied it. So what we are getting it from here, if after multiplying. So what we have, 1 plus √3 into √7 multiplied by 1 minus 3 to the power of n upon 2 whole divided by, this will become a square minus b square. So 1 square minus √3 square. Okay. So this again, what you can write, √7, 1 plus √3, 1 minus 3 to the power of n by 2 whole divided by 1 minus what? 3. So this will become minus 2, right? Minus √7 upon 2, 1 plus √3 multiplied by 1 minus 3. This again, you can, what you can do, you can take minus here inside the bracket. Okay, you can take this minus inside the bracket. So what you can write? You can write √7 by 2, 1 plus √3, 3 to the power of n by 2 minus 1. You can write anything, any way you want. Okay, so this all is your answer. Okay, got it? Yes or no?
Yes.
Okay. Solve. Yeah, Tivya, you got it, or do you have any problem in this solving this number?
Yes, sir, we got it. Sir.
Got it. Shreya, let me check who else is there in class. I've been got it. Why you guys are so sad? Abhinav, you are not answering here. Hari Raghav is also here. Naveen is there, but he will not answer. Who is
Sir,
S
understood.
Mitran? Who is S Mitran? Huh?
Yes, sir.
Who is this?
Sir, I have newly joined today.
Oh, you have joined. This is your first class.
Yes, sir.
Okay, which school you are from?
I'm from Prasan Vidya Mandir, Mamandur.
Okay, got it. Got it. I understood completely. Fine. Thanks.
Welcome.
So, all right. Naveen, you understood, you are getting things from this class. If you have doubt, you are very much welcome to ask. Okay.
Sure, sir.
What is this? Who is this? This is Srinidhi, right? Find the sum of n terms of the following series. So you got it. You got the answer, Nidhi. What is this? Nidhi? Not here.
Yes,
Are you
sir.
guys even there in class? Okay. Okay. Whew. Okay, solve problem number 11. So it says evaluate summation of k is equal to k is equal to 1 from 1 to 11, right? And what's the sum given? 2 plus 3 to the power of k. What's the meaning of this? How you will write it? So you have to sum up these. How you will do that? Anyone?
So in place of k, we should
Yes.
put numbers from 1 to 11.
Write down the terms and tell me. From 1 to 11 it is, right? So you will substitute k from 1 to 11. Write down. Please tell me what you are getting. Yeah, got it. Shreya, tell me. Hari Raghav. Yes, sir. Hari Raghav, sir.
Sir,
Yes, tell me what you got. Tell me, yaar.
not done, sir.
What? How
Not
do you
done,
write?
sir.
How? Yeah, I know you haven't done it yet. How you will write? How you are going to write this? Shri Kruti.
Read the,
See the meaning. See, when you are writing summation of x to the power of n, let's say n, and n is from 1 to 5, let's say 5. The meaning is you keep substituting n is equal to 1 to 5 and adding the terms. This symbol means summation. Okay, you have to sum up. So, and so you can write x to the power of 1 plus x square plus x cube plus x to the power of 4 plus x to the power of 5. That's the meaning. So here you have to sum from 1 to 11. That means 2 plus 3 to the power of 1. First you got. Now you will substitute k is equal to 2 plus k is equal to 2 if you put. So 2 plus 3 square plus 2 plus 3 cube. Okay. Just a minute. Okay, so you will add till 11 terms plus 2 plus 3 to the power of 10 plus 2 plus 3 to the power of 11. So these are the terms that you are getting here. Now let's write down. See, now 2 will appear. Let's write down here. 2 will appear 11 times. Now that means you will have to add 2 11 times. That means 2 multiplied by 11. So we are done with 2 plus 3 square plus 3 cube plus up to 3 to the power of 11. Now see, this series is in GP, right? Yes or no?
Yes, sir.
So this is in GP and this, so already you know 22. Do that. Yeah,
Sir,
new
so
book.
Rn is 311. 3 power 11 minus 1.
Okay, so I don't know. I don't know the answer. Let's write it down. So this will be equal to 22 plus Sn. Okay, Sn of the GP. Okay, and for this Sn, your A value is 3. Common ratio is how much? 3 only, right? 3.
Yes, sir.
Okay. So 22 and n is equal to 11 terms. So we write A Sn, we know Sn is equal to A r to the power of n minus 1 upon r minus 1. So use this. A is 3, r is how much? 3 to the power of how much? 10, 11 minus 1 whole divided by what? R minus 1. R minus 1 will be 10. R, sorry. R is 3 now, so 2 it will be, isn't it?
Yes,
Okay.
sir.
So this will be equal to 22 plus, let's write 3 by 2, 3 to the power of 11 minus 1. Is that okay? So summation of this series, summation of this. See, any GP can also be written as Sn is equal to what? You are just summing up the terms, right? You're just summing it up, isn't it? So how we can write the GP? Sn of a GP, how we can write? Anyone? Don't know? Leave it. Because see, you're just adding up all the terms. So any term, An is written how? Ar to the power of n minus 1. So you just sum this thing up, no? You'll add what? S1, A1 plus A2 plus A3. I have done the derivation also, right? In previous class. So this is your final answer, by the way. So the see, first term is what? Ar to the power of n minus, sorry. First term is A, second term is AR, third term is AR square, fourth term is AR cube, and so on, right? So that means you are summing up A r to the power of n minus 1, where n is starts from what? 0 to n, right? Is it? Yes or no?
Yes, sir.
Yes, sir.
Is this correct? Anyone tell me, is it correct? It's not correct, yeah. If you start from n is equal to 0, so just substitute it here, what you will get? For n is equal to 0, is A r to the power of 0 minus 1. A r to the power of minus 1. We don't write the first term like that. Means you can write it, but we don't usually use this notation. Okay, we keep n as a natural number. So we start n from 1. Okay, that's how we write it. Okay. Oh, why nobody is answering? Yeah, what happened to you guys? Okay, let's solve problem number 11th. We are done. Let's come to miscellaneous. I think all the problems are easy. Anybody is need to ask any problem from this exercise? Solve question number 17. All are similar problems. You just need to write the term. You just need to know this, the final term or the last term of an. This is actually nth term. An or the last term is equal to ar to the power of n minus 1. And Sn is equal to what? Ar to the power of n minus 1 upon r minus 1. That's it. And if you need to find, we have in previous class we have done this also, no? Sn minus 2, right? Something like that we have done, no? We have solved this type of problems, right? Yes or no? Huh? Shreya, you were there in class, right? Who was there in the previous class? Nidhi, you want the answer of this problem? At the end, I'll give you, okay?
Yes, sir.
Yeah. All right. Solve this problem. Question number 17 from your book. If the 4th, 10th, and 16th term of the GP is XYZ, prove that XYZ are in GP. Okay. See, if X, Y, Z are in GP, what do you mean? How do you prove that these are in GP? See, the common ratio, right? That means Z by Y should be equal to Y by X, or Y square should be equal to XZ. You have to prove this. If you can prove this, that means XYZ is in GP. Do that. Done? Why you guys are not talking here? Nobody is saying anything. Abhinav, what happened? Huh? Why
Sir,
you
it is
guys
in
are
GP.
not? Huh?
It is in GP, sir.
GP, is it? Okay. How many of you are not able to prove that? Okay, so let A be the first term and R be the common ratio, obviously. So we know you have to write this. Let A be the first term and R the common ratio. Okay. So with this, what we can write? A4, fourth term we can write, right? So it's given fourth term. So T4 or A4 is equal to AR cube. Let's say 1. 10th term is also given, or A10 also you can say. AR to the power 9. What else is given? 16th. Fine. These three are given. Fine. Is it or not? It's given as X, Y, and Z. Sorry. Okay. Okay, let me write it again. This is equal to X is equal to Y is equal to Z. Now you have to prove that Y square is equal to X into Z. Fine. So just start. It's the same problem that we did before. What we did is the same problem. Y square, that means this. So AR9 square is equal to X AR cube multiplied by AR to the power 15. So this is A square. R to the power of 9 into 2 is 18. So this will be equal to A square R3 plus 15. This will be A square R to the power of 18. So LHS is equal to RHS. Proved. Okay. Question number 18. Okay, question number 18. Good question. You have to find the sum first. Sn you need to find out. Sum of first n terms. Okay. Of the series 8, 88, 888, and so on. So tell me whether this series, which type of series is this? Tell me. What type of series is this? Is this AP or GP? Give me a minute, I'll be back. Yeah, whether it is in AP or GP.
GP.
GP, who is saying this? Who is this?
Shreya, sir.
Huh? Sorry, I didn't get you.
Shreya, sir.
Okay, GP. How is that GP?
They don't have the common difference, sir.
Common difference.
So they aren't AP.
They have common difference. Okay.
They don't
8.
have common difference.
So they are not AP, you are saying.
Yes, sir.
That means they are GP. Okay, tell me 1, 1, 2, 3, 5, 8, 13. This is in AP or GP? Divya? Anyone, is this AP or GP? What type of series is it? Huh?
Not both.
This is neither. See, AP means it should have a common difference. That means 13 minus 8 should be equal to 8 minus 5 should be equal to 5 minus 3. Are they equal? 13 minus 8 is 5, 3. This is equal to how much? 2. So they are not equal, right? That means they do not have a common difference. So this is not AP. Okay, fine. GP means they should have a common ratio. 13 upon 8 is equal to 8 upon 5. Is it? Is it? It's not. So it's not GP also. It's a spatial series. Let's not talk about that series. We haven't discussed it. So whether this is in AP or GP. So just divide it, 888 divided by 88. How much you are getting? Huh? How much you are getting here? Anyone, please tell me how much is
11,
88?
sir.
Uh-huh. See, just divide it, use
10.09.
not 0.0. Tell me in fraction, how much you will get?
10 point something.
Fraction. You tell me in fraction. One divided by 11, right? That's what you will get, no?
Yes,
Yes
sir.
or no? Yes or no? Tell me. 1 upon 11. Is this
Yes,
correct?
sir.
Okay. Now 88 divided by 8. How much you are getting? Hmm?
11.
11. So are they equal? Are they two equal? 1 upon 11 is equal to 11. Is it possible?
No, sir.
No, right? Because 11 into 11 we know is 121, right? If you multiply it is 121. So this is not in GP. Okay, not in GP. Let me raise the second one also. Not in GP. See, we have studied only AP and GP. So if this term is not in GP, why this problem is here in our book? Because the only possible reason is it can be converted to either AP or GP. Okay, from the look, means the number is really it's really apart. These three numbers are really apart, right? The next term in the series is given 8888, right? Isn't it? So the number is like that. So it cannot be AP because the difference will never match. What we can do, we can take 8 common in this number. So actually what we need to find out SN, who's 8 plus 88 plus 888 plus 8888 and plus so on. It will keep going on like that. Okay, to n terms. Right? Yeah. So what you will do, you just take 8 common. Now what you will get here? 1 plus 11 plus 1, 1, 1, right? Plus 1, 1, 1, 1, plus so on up to n terms. I'm not writing up to n terms all the time. Okay, you just understand up to n terms we are going. Okay, not infinity, up to nth term. I'll just write nth. Okay. Now again, these terms, this is also not GP. Of course, this inside all term is also not GP because we have just taken 8 common. How can we make this GP? We need a common difference, common ratio. We need that, right? So yes or no?
Yes,
See,
sir.
either what we can do, we can multiply, we can write this as 1 plus 10 plus 1 plus, what else we can write? 10 square plus 1. We can write like this. Okay, up to nth term. Or we can also write this as, see, again, the first term is not matching with, it's not the factor of 10. Okay, so it will be difficult. What we can do, we can multiply the whole term, this equation number 1. Let's say this equation number 1, multiply the numerator and the denominator by 9. Why we are multiplying by 9 only? So this will become 8 by 9 multiplied by 9 plus 99 plus 999 plus so on up to n terms. What we can do here? Now we can write 8 upon 9. So now we can write in terms of 10. 10 minus 1 plus 10 square minus 1 plus 10 cube minus 1 plus up to n times. You can also use this series. Okay, this will be a little lengthy, but again you will get the answer same. Okay, it's not like it is different. You can again get the answer from here also, from equation number 2 also. I can show you that as well, but this one is little easier to find out. Okay, we'll see how. And this will be equal to 8 upon 9. Now can we write all 10 together? So what we can write, 10 plus 10 square plus 10 cube plus up to n times. Total n terms are there, nth term, nth times. So this is 10, but again we have ones also, this one, this one, this one. So minus, we'll take minus common in all one, and we can write 1 plus 1 plus up to how many times? N times. Fine. Yes or no? Now see, this one is in GP. This one is in GP. Yes. It has a common ratio. What's the common ratio here? Huh? This is equal to 8 upon 9. 10 plus 10 square plus so on up to n times minus 1. So by the way, it is being multiplied in whole. Okay, 1 plus 1 plus up to n times. Okay, so this will be 8 upon 9. So this is GP. So the first term A is 10. Common ratio R is also 10. So what we can write, 10 to the power of n minus 1 whole divided by 10 minus 1, right? And this n times, so it will be n, because 1 plus 2 plus 3 plus 4 plus 5 of 1 plus 1 plus 1 plus 1, if you add n number of times, you just multiply 1 into n, right? So n, that's how we get it. So how much this will become? So we can take this, okay, we can write 8 upon 9 multiplied by 10 to the power of n minus 1 upon 9 minus n. Is that okay? So this is your answer. Fine. If you want to expand even more, you can do that. You can either multiply this. Okay, what you can do, you can multiply this. You can take a 9 as common, this LCM here in this term. Okay, so what you can write, so 10 to the 10 square minus, 10 to the power n minus 1 whole divided by 9, and this will be 9n. So this you can write 81 upon 9, sorry, 80 upon 9, 81 whole multiplied by 10 to the power of n minus 1, right? This will become that, isn't it? So let me write it. 8 upon 9. You can also multiply this 10 here as well as here. No issues. 10 multiplied by 10 to the power of n minus 1 minus 9n. We have taken LCM 9. This will become 10. Okay, so what you can take? You can take this 10 common outside. So you can write. Or just leave it like that. It doesn't matter. 8 upon 81 into, you can multiply this 10 to the power of n plus 1 minus 10 minus 9n. This is again one of your answer. Okay. Nidhi, you got it? Nidhi, is there any doubt, Nidhi? So this term can be
Sir?
converted. Yeah, you have. Yeah, Divya, yes.
Yes, sir. Why are we dividing it by 9? Multiplying it.
Yeah, so we can directly do it from here also. Same thing. Okay, do you want to do that? I multiplied it so that we can write in terms of this. This first term also we can write in terms of 10. Okay,
So
so
why
if,
is it specifically taking 9?
see, because if you let's say you multiply by 8, okay, 8, then it will become 10 minus 2, okay, plus, okay, then what will be next term? Sorry, because you will not get uniform one everywhere. You will get some other numbers. You will get, say, this one we are getting, no, 1, or here also we are getting these ones. Instead of these ones, first number will be what? Let's do it from here. So this term you can write 10 minus 2. This you will write 100 minus 12, right? Isn't it? So you are not getting that 1. You're understanding this. Plus you means if you want, you will not get 2. So here what you will write? 1000. That means 1000 minus how much it is? 22, right? See these numbers, how you will, again you'll have to add these numbers. Can you see that? See, I'll explain you again here. See, this question is important. Let's understand. 8 plus 88 plus 888 plus so on. Okay. See, when we are writing in terms of 10, then only we can make it in GP. Right now, this number is not in GP. Okay. Now, this number you can write 10 minus 2, first number. Second number you can write 100 minus 12. Third number you can write 1000 minus 22, and so on, like that, up to n terms. See, here what you are getting, 10 plus 10 square plus 10 cube. These terms you are able to write. Okay, up to n times. Okay, n times. But again, what you are getting here, minus 2 plus 12 plus 22. Now, these numbers are not in a sequence or a series that we know of. Okay, these numbers are not. Again, we have to manipulate these numbers to become some kind of series. Then only we will be able to find the sum of these numbers. You're getting my point? Why we are why we are taking 8 as common. Understood this part? And why we are multiplying it by 9 only, you said, no? Divya.
Sir?
Yeah. You are getting this point or not? Means why we cannot directly solve using this first.
Yes, sir.
Now you said why you are multiplying it by 9. Okay, 9 by 9. Okay, I said just to make it easier, let's take equation number 2. Okay, 8 multiplied by 1 plus, what's the term? We'll get 1 plus 11 plus 1, 11. Fine. Okay. Up to n times. So 8, what you can write, 10 minus 1, this first one, plus 10 square. Sorry. sorry. First term you can write 1 plus. Now this 11, what you can write 10 plus 1. This what you can write 100, 10 square. How much? 10 square plus 11. Fine. Next will be how much? 10 cube plus this is 1 1 1 1. Yes, right? 10 cube plus 1 1 1. Okay. Divya, you're getting it. Why it will be difficult? Let's see. So 8 plus, now we have these numbers. 10, again we are getting this series GP. 10 plus 10 square plus up to 10 to the power of n minus 1, because the total number of terms are n, but this term is not having, we are not writing in terms of 10. Okay. So 10 we are not getting out from here. This plus 1 plus 1 plus again from here also 1 plus from here 11 plus here 1 1 1 plus 1 1 1 1. Now see here again, this series we don't know about this series. We cannot solve this series. 1 plus 1 is 2. Okay, 11. We don't have any general formula, no general formula available for this unknown series. Okay, this is also unknown series. This is also unknown series. Then why we are multiplying this by? Now let's come to the third point. Understood why we cannot solve using this and this? See,
Yes,
we
sir.
can solve it, but the thing is again we have to manipulate these series. Okay, it will again take a longer time. This also we have to manipulate the series to become some AP, GP or something, or harmonic progression. Then only we'll be able, or infinite series, then only we'll be able to solve it. Otherwise we don't have a general formula. We have a general formulas for GP, AP and HP that is not there in your syllabus, but anyway, and other series are there, infinite, exponential series, logarithmic series. These series are there, which you don't have to study, I guess. Okay, so there are specific series for which we have formula, and that's what we are studying. Now what happens if we multiply it by 9? See, when we multiplied it by 9, so what happened? We made the series in such that we can get factors, means every time this factor is 1, right? When we are subtracting it, we are getting 1. So 10 minus 1 is 9, 100 minus 1 is 99, 1000 minus 1 is 999, and so on. It will keep going on. You see, we are getting a uniform number here. So this series we know how to add. Any number is available 100 times. How you will add 1 plus 1 plus 1 plus 1 up to 100 times? That means 100 and 100 into 1, right? So that's what we are, if it is n times, so we will just write 1 into n. Got it? So we know how to add these, but we don't know how to add these two, this and this. You understood my point? Now you understood why we multiplied it, why we multiplied it by this 9. And since we are multiplying this by 9, so you have to divide it by 9 to make it same, so that 9 get cancelled and it will be, the series will be same, right? And that's why there is a 9 in the denominator. Okay, so we have just multiplied the numerator as well as the denominator by the number 9. Okay, to get same kind of factor. Understood or not?
Yes, sir.
Divya, do you have any other doubts in this?
No, sir. I understood.
Understood now why we are doing it?
Yes,
It's
sir.
just to make, just because we know how to add these, but we don't know how to add these and these. Okay. All right. So that will be all of AM and G. Sorry, again, mean, we will discuss mean in this tomorrow's class. Okay. Arithmetic mean and geometric mean, because both are related. See, mean is just, I'll just tell you a few things about mean. Arithmetic mean, when we are saying, like, it's literally the middle one. Okay, so if you have 3 numbers, A, B and C, and we need to find, if we say that these 3 numbers are in AP, Tell me any number in AP, like 2, 4, 6. So how you can get B? 6 plus 2 divided by what? Sorry, 6 plus 2 plus 4 divided by 3, right? So you add these three numbers, that means AM will be equal to A plus B plus C divided by how many numbers are there? 3. So that you will get as that is your arithmetic mean. So for two numbers A and B, the arithmetic mean will be what? A plus B by 2. Okay, that means they have a common difference, and these numbers are in arithmetic progression, AP. Okay, or arithmetic series these are in. So this is AP, and GP. GP has a common ratio. All the terms of a GP are in common ratio, right? Yes or no?
Yes.
That means, let's say if A, B, and C are in GP, geometric progression. So how do you write geometric mean? So, okay, let's leave it. Let's leave this part. See, let's say there are two numbers, A and B. How do we write the geometric mean of this number, these two numbers? So how do we write it? If G, let's say G be the geometric mean. Okay, so A by G will be equal, sorry, A by G will be equal to G by B, or you can write the opposite as well. A, that means A, G by A will be equal to B by G. This means if you could cross multiply, G square is equal to AB and G is equal to square root of AB. So these two, these two, whatever I have given, arithmetic mean and geometric mean. So these are called single geometric mean or single arithmetic mean. Okay, this is single arithmetic mean. So we will discuss about sum of arithmetic means, okay, and how it is related to geometric means. That will be, I think, the last topic of this chapter. Okay, and
I guess it's not in the syllabus.
who said previous class? So somebody was saying it is there now. See, even if it is not there, we are going to study about, see, we studied AP, right? Arithmetic progression. We are going to study about geometric mean. By that time, solve exercise 7.3. Complete questions other than GM, geometric mean. Other than this and miscellaneous. Okay, plus miscellaneous also. So other than geometric mean, you solve all the problems. If you have doubt, let me know. Okay, see you tomorrow. Bye. Tomorrow we'll have class from 6:30. Okay, 6:30 to 8 o'clock. Tomorrow and day after. Okay, those who don't want to join, it's okay. But tomorrow we'll have this mini 1.5 hour class. Okay, see you. Bye.
Thank you, sir.
See, solve problems and ask me doubts, sir. Without that, you will not learn. Please understand this.
Yes, sir.
Anyway, okay, bye.